Hello everyone and welcome back to our videos. Today it will be the last video about the turbine engine overhaul, and we will start with the fourth procedure, repair. The repair method used to build up the component and restore it to original dimension. Method of repair, we have three methods: plasma coating, ceramic coating, and additional welding processes. The plasma coating, it's one of the popular techniques proven to extend the surface life of the plates and vanes by spraying an atomized metallic material onto the base metal of the part. Ionized argon gas, heated to 50,000 Fahrenheit at high velocity and high heat. Metallic powder is then introduced into the gas stream, causing a coat of molten metallic to the airfoil. The second coating is ceramic coating, used to coat a compressor part for corrosion protection. This method produced smooth surface that reduced air friction and surface drag. The last method of repair is additional welding processes, used to build up the engine component to serviceable limit, such as the electron beam welding. This method used to make repair to the compressor airfoil constructed from titanium alloy. When done properly, electron beam is stronger than a new blade. Compressor section repair. The most common repair made of compressor blade is the removal of foreign object damage from blade and vane, and that will be done by blending, by remove the damage by hand tool like common files, emery, crocus cloths, and carborundum stones. They are made or they are used on blend repair. Blend repair has a length to the depth ratio 4:1 and is complete in several methods, which includes: the first one, the damage area is scalloped by filling enough material away to create a saddle or dashed out shape. The second one, stone or finish file, is used to smooth out, score, make radius the edges of the repair. Number 3, the repair is polished with emery or crocus cloth to restore the original finish. The repair blade must inspect by magnetic particle or dye penetrant and repair area marked with fill tip dye. Note the amount of damage that permissible on engine fan blade, inlet, guidance fan, and compressor blade differ from engine to engine. Therefore, it's important to refer to the manufacturer repair manual. For example, if an inlet guide fins become damaged and the damage doesn't penetrate the outer shell of the vane, that damage can be blended and countered. Here we have the damage of the blade before blending, and here after the blending, and this permissible. Combustion chamber repair. Several methods used to restore the combustion section, such as crack, can be welded, while some worn component can be restored using ceramic coating. Turbine section repair. The amount of damage permissible in the turbine section differ from one manufacturer to another. A maximum 3 neck dent bits are permitted within quarter-inch of a filter. Another type of damage in turbine section, erosion, which can be repaired by weld processes using electron beam welding. Another technique used to repair the erosion by plasma coating. Turbine nozzle vane. The damage can be repaired. Dent, nicks, scratches are repaired by using blending and contouring techniques. If bowed, it can be strining. If the strining is not permitted, the area cut away and the new base of blade material can be welded in place, as we see here in this figure. Exhaust section repair. Damage in exhaust section can be repaired include warping, bulking, and crack. Warping and bulking can be repaired by strining. Crack can be welded by using electron beam weld or gas. After repair, we have the fifth procedure, balancing. If the turbine engine is not balanced, severe vibration can occur. To ensure the proper balance in both compressor and turbine blade, replacement of the blades is accomplished by installing a new blade with an equal moment to weight. Turbine blades must be checked for the both static and dynamic balance to ensure that the main rotating assembly is balanced both in rotational plane and along the rotor axis. Note that if a blade having the exact same moment to weight is not available to replace the damaged blade, blade replacement on a compressor or turbine wheel having an even number of blades is accomplished by replacing two blades with equal moment to weight. What that means? If we have a blade of a turbine or compressor and this blade, the location of it's here in 12 o'clock. If this damaged, we will replace this damaged blade and another one in front of or in 180 degree with, so here we will change two with the same moment weight. But if we have odded, as we read here, if the compressor or turbine wheel has an odd number of blades, replacement is done by replacing the damaged blade and each blade 120 degree to the left or right of the damaged blade. For example, if we have two blades replaced, this area and this area, we will make 3 replacement of the blade, and the degree between them it will be 120, but the blade must have the same moment to weight. Procedure number 6, reassembly. The reassembly procedures is basically the reverse processes of engine disassembly. The same tool and fixture that disassemble the gas turbine engine used to reassembly. Torque wrench are used to ensure the components are properly torqued. These parts must be replaced regardless of condition when reassembly the engine during overhaul, such as bearing, seal, gasket, o-ring, lock wire, lock wrench, lock tab, cutter pin. Number 7. Engine testing. The final step in overhaul process is to test the engine. If failure of an engine accessories occurs, the new accessory is installed and the block test is continued. Engine installation. After we finish the overhaul, we will install our engine. After the engine repaired, overhaul or replaced, the engine prepared to installation. Return the engine to the configuration it was immediately after it was removed. If the engine was preserved in storage, depreservation procedure is followed. Mounting the engine. Before the engine installed in the aircraft, the engine mount must be inspected and checked. With dolly or hoist engine installation, the safety must be taken. After we install the engine on the aircraft, connection and adjustment. The bleed air connected and torque, fuel lines hoses, idle clamps used to support and rotate away from engine or airframe parts that could damage. Metal tubing with threaded. Make sure that threads clean and in good condition. The power lever control should be installed using the proper method. Engine control must have caution or spring back at its fully open and fully closed. Electrical leads are clean and secured. Engine alignment. After a new engine or replacement turbine engine is installed in helicopter, it's very important to check the alignment of the engine to transmission. Alignment is accomplished by shaping the mount legs between the fuselage and the engine mounts. The last thing we will talk about engine trimming. Engine trimming refers to process that an engine fuel control is adjusted to allow an engine produce its maximum rated thrust. Engine trimming performed when after engine change, after fuel control unit change, whenever engine doesn't produce its maximum thrust. Manual trimming procedures vary from engine to another model. Therefore, you should follow the specific procedures in the engine maintenance manual. The aircraft should be pointed into the wind. Here we have an example of trimming of the engine, and this is the location of the trimming.